I want to introduce one more presenter, Jeannie Albrecht from Williams. Now, Jeannie's going to show us how we're attacking a sort of a different problem. And one of our goals in GENI is to make accessible to young researchers or young potential researchers the kinds of tools that would allow them to get started doing research in networking and distributed computing. And Jeannie Albrecht is going to show how she's using GENI resources to do exactly that. Jeannie?
Thanks, Mark. Okay. So we've heard a lot of presentations, and we'll hear some more later today, that highlight some of the exciting research that's going on GENI. And so as Mark said, I'm going to take a slightly different angle for the last few minutes of this session and tell you a little bit about some of the educational benefits that I've been sort of experimenting with at Williams College. So when I started at Williams in the fall of 2007, they let me sort of design a new course. And so I said, well, hey, I want to do distributed systems. And so then I set out to design this course, and I started searching the web for other courses, of course, right? Why not? And I was somewhat surprised to find that very few schools actually offer undergraduate distributed systems courses. So then I started poking in at network syllabi and found that, well, they usually cover systems, but what they cover is usually a very theoretical side of distributed systems. You know, consensus, consistency, all very, very important things. But very few actually gave the students a chance to experiment with sort of real resources and real implementations and real deployments. And so I set out to sort of, you know, I was involved with GENI, and I thought, well, hey, there's an opportunity here. We should really be able to address this limitation. I felt that the students weren't really getting accurately prepared for life beyond college without having this experience with real systems on real machines and so on. So I designed this course, and the goal was to focus on the design and implementation of systems, but also the evaluation aspect. And I think that's something that had been lacking previously. And I think the reason it's lacking is fundamentally because many colleges and universities, especially small colleges, don't have the infrastructure necessary to actually do large-scale distributed computing on their, on their local machines. We probably are lucky at Williams, and our cluster consists of like 18 machines that range from 1 to 5 years old. I mean, so we just literally don't have the resources necessary to do some of this experimentation. But GENI can change that, right? GENI gives us a chance to actually to fix this problem. And so in this demo, I don't have time to go into all the details of the course, but I'm going to highlight sort of one project that have not tried yet, but will be trying the next time I offer this. I've offered the course twice so far, and I'm constantly updating things. So this is a new project. It's just a simple project, again, designed for undergrads, and the goal is to just explore different caching policies in a simple content distribution network, and again, we're going to test this on GENI. So I'll just take a second to give you some background about, if you're unfamiliar with liberal arts colleges and so on. Williams is a liberal arts college. As most liberal arts colleges, it's located in a tiny, tiny town in western Massachusetts. Almost all undergrad. So we have 50 graduate students in a very unique program in developmental economics or something. So, I mean, 2,200 students, and they're almost entirely undergrad. The big benefit of a liberal arts college, or one of the benefits that they like to tell you about, is the small class sizes. So student-to-faculty ratio is about 7 to 1. So our classes are pretty small. Computer science in particular at Williams, we get about 15 majors a year, about 3 women. It's very, very common for students to double major and be involved in many other things. And they typically aren't double majoring in other sciences. Actually, we see double majors in music and Chinese and history, all over the place. About 4 students each year end up going on to top graduate schools. We have 7 active faculty members in our department, and a big class. In fact, I complained a lot when I had 28 students in a class once. We get about 25 in our low-level courses, and as few as 10 or even less than that in some of our upper-level electives. So this new course that I developed, Distributed Systems, like I said, it's been offered twice now. It's a 300-level course, so we're targeting mostly juniors and seniors, a handful of ambitious sophomores as well. The only prereqs are data structures and computer organization. So the students they know how to program, they have some familiarity with a Unix programming environment, but they certainly aren't grad students, right? So they aren't experts, they don't know how to write scripts. So just running on multiple machines sometimes is a challenge. The course is a designated project course at Williams, and that basically means that there is sort of a software engineering aspect in there, meaning that there has to be some emphasis on actual programming projects that are bigger than sort of your standard, weekly lab that you might see in an intro course. So my course, I had 4 projects that I spread across the semester, with the final couple weeks being for a final project that was a bit more intense than the others. The goal of the projects was, again, not to have them code their brains out. I mean, they should do some coding, but I also really wanted them to learn about evaluation, right? They should learn more than just writing the code. You have to be able to evaluate your code and prove that your code does what it should do. And the big thing that they initially hate, but later come back and actually they're starting to thank me for this, is I make them do sort of a research paper style document with every project that they do. And we read papers, but it takes a while to get them to understand how to do this, but we do actually read research papers in the course. And they learn how to write an introduction, they learn how to write an evaluation section, and so they develop the skills to use GNU plot, things like this. And so part of the project is teaching them the full cycle, right, from beginning to end, not just doing the code in the middle, and I think that's important. And so that's all I'm going to say about the course. If you'd like to know more, there's my webpage, and I'm happy to answer questions later, and I also wrote a SIGSI paper about this in 2009. Okay, so moving on, I just want to now talk about this particular project, the new CDN project. And at a high level, the goal of the project, or sort of the project statement, is just given a simple CDN, simple content distribution network, implement one or more caching strategies, and then evaluate these strategies. And so part of this is, I don't give them any more information about how to do the evaluation. So in developing their strategies, right, they're going to have to pick certain metrics that they're trying to optimize for. And so part of this is having them think about what metrics actually matter, and then also how do they actually go about evaluating whether or not their algorithms were successful at achieving their goals and so on. And then again, use GENI resources for deployment and experimentation, and I'm always helping them get this sort of up and running. And I promised the students who posed for this picture that I would say this. This is a picture of both GENI with a G and a J in the classroom. So I fulfilled my end of the bargain. All right, so some of the details of the project. Since I don't want them to spend the entire 4 weeks that I give them on this project writing the CDN, we're going to give them a simple CDN, right? Just a very basic Python content distribution network that they don't have to spend time actually building the CDN itself. I really want them to focus on the caching strategies here. And then inside of the code we give them, we also will give them a sample, simple caching strategy. Maybe it just does random page replacement, for example, just so they know how the code works, how the library works, and so they have a place to start. Then their goal is to simply implement one or more of these caching algorithms, hopefully more sophisticated than random, but certainly they should evaluate random as a baseline. And again, think about what metrics matter and think about how to evaluate these, because I really think that for some of them, that's hard. They don't really get to that point as undergrads. And I encourage them to scour the web, check out the GENI webpage, figure out how to use the existing experimenter tools that are out there. And so this is something I've been working on sort of, within GENI. I think that there's a huge, opportunity here to really make these resources more accessible to undergrads. And so I encourage them to learn how to use these tools. And the feedback is valuable for those of us developing the tools anyway. And so in this particular case, in this, what I'm going to show you, we're using a combination of Planet Lab resources for their client machines and ProtoGenie servers for their actual CDN. The reason being, ProtoGenie allows us to configure the servers to be sort of what we want, and Planet Lab has the benefit of having the geographical diversity as well as the somewhat unpredictable usage pattern since it is a shared platform. Okay, so here we have, this is actually one of my advisees, Emily Yu. She's a graduating senior, is a double major in Chinese and computer science. And she has chosen to implement a very simple caching policy. In particular, it's least recently used, LRU. So what you will see eventually over here, we'll start here, is this is Emily's system actually up and running. So you can see we have the ProtoGenie servers sitting at Utah and Kentucky, and then we have an assortment of Planet Lab machines out there acting as the clients. And what you would expect to see, and again, these are just examples. Emily may choose to evaluate something totally differently. But on the clients, what we really care about is probably latency. Right? We want to have low latency in the clients. And then the efficiency metric that you see here on the servers is some measure of how effective the caching algorithm actually is. So think of it as maybe bytes provided by the CDN over bytes provided by the original server. So high efficiency is good. And then on the map over here, you basically are just seeing what resources are actually being used. So you can see We have 2 students, Emily and Kaylee. We'll see Kaylee next. Kaylee's running 2 different experiments, and they're using a combination of the Proto-GENI resources, the servers, as you can see, and then the blue and the green stars are all Planet Lab machines. Green are actually being used, blue are the ones that are actually available, and these are the machines that are actually hosting the experiments my students are running. Okay, so this is Emily. Then my next student, Kaylee Warehouser, also a graduating senior. She is a psych and computer science double major. She has chosen to implement a more sophisticated policy. So she's actually trying to do some predicting. And the idea here is, well, hey, if I download the first frame of a YouTube video, there's a good chance I'm going to download frames 2 and 3 as well. So not the most, no machine learning or anything crazy going on here, but something that tries to be a bit more intelligent and do some more effective caching. And Kaylee is actually testing 2 different things here. She's using I believe, on the left, a sort of typical client usage pattern where the clients are actually doing what we'd expect, right? If I download a YouTube video, I download the whole YouTube video, for example. And then sort of the worst case on the right, where we're actually looking at maybe the clients are just using random pages or just accessing random pages. So we'd expect the prediction to not be as useful. And so again, what we would hope to see, and hopefully we are, if not, Kaylee needs to go back and figure it out. And maybe I've flipped them because the latency actually looks higher over here, right? But Kaylee has some debugging to do if that's the case. But we'd expect to see that on the case where the clients are doing the typical pattern, we'd expect to see lower latency at the clients because they're actually benefiting more from the caching and the prediction. And we'd expect to see higher efficiency in that case as well. And so the idea here is that the students, they're not using a ton of resources, right? Because that's overwhelming, but it's still much more than they've had to deal with in the past. I mean, simulation is great, and they can do a lot with simulation, but I think combining a simulation with an actual deployment, really adds something to their experience. And I've had them go off and graduate and come back and say, I'm so glad, you taught us how to do this sort of thing. And so I think undergrads really have an opportunity here to really benefit from what GENI has to offer. Okay, so to summarize, as I just said, I think that the students really benefit from the opportunity to use real systems in real environments. Emphasis on real, right? I mean, I think that the combination of simulating and learning the pen and paper sort of exercises in these courses combined with what GENI can give us and actually allow our students to deploy in the real world, I think that's the right balance. I think they need to do both to really get a feel for what they're going to be doing after they graduate. And as I mentioned, many curriculums currently don't give them this hands-on experience, and that's fundamentally because they haven't had the ability to. They just haven't had the machines. So GENI gives us a chance to bring this technological richness, especially to small schools, where they just literally don't have the infrastructure required to actually do these experiments without them. Just as a little plug for the work I've been doing, now, it's great that we have all these resources out there, but of course, handing a bunch of undergrads, 200 machines and saying go, right, that's maybe not the best thing in the world either. So there's also a need for tools that actually simplify some of the challenges associated with deployment and evaluation. And so one project I've been working on is called Gush. There's other ones out there that really aims to make it easier to use GENI. So now that we have GENI and it's up and running and students can run things on it, can we simplify some of the steps involved with actually getting their code out there, running these evaluations, so that the students can really focus on what matters and not sort of, not many of my students can write a script when they start my class. And I don't think that's necessarily the most important or best use of their time. If you want more information about this sort of thing, as we mentioned, there's a working group meeting tomorrow morning that focuses on some of these ideas. And so moving forward from the educational standpoint, I'd really like to see more schools offering these distributed systems courses to undergrads. I mean, and grad students as well. I mean, there's clear benefit here for them as well. And more assignments. I mean, the CDN is one example. I've got some other ones that I've been playing with, but that really leverages the combination of resources out there, that really takes advantage of the diversity of resources that GENI has to offer. And I think that's it. Thank you.